Hey everyone, today we are going to look into a fundamental concept which underpins modern networking, the OSI model or the Open Systems Interconnection model. This model is essential for understanding how different network devices communicate and interact. It's a framework that helps us to comprehend the intricacies of data transmission, which ensures seamless communication across diverse network systems. Let's get started. The OSI model, introduced by the International Organization for Standardization, or ISO, in 1984, serves as a guide for designing and understanding network architectures. It provides a standardized way to ensure communication between systems, regardless of their underlying structure or vendor. The OSI model is divided into 7 layers, each with its specific role and function. Physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and the application layer. Let's look more closely into each of these layers, starting from the bottom to up. First, physical layer. This is the lowest layer of the OSI model, concerned with the physical connection between devices. It defines the hardware elements like cables, switches, and network adapters. The key functions include signal transmission, bitrate control, and physical topology. For instance, when you plug in an Ethernet cable, you are interacting with the physical layer. Second, data link layer. The data link layer ensures reliable data transfer between two directly connected nodes. It's responsible for MAC addresses, which is the media access control addresses, and error detection or correction. This layer can be divided into 2 sub-layers, the logical link control, LLC, and MAC. When your Wi-Fi router sends data packets to your laptop, it operates at this layer. Third, network layer. The network layer handles the routing of data across networks. It's where IP addressing and packet forwarding takes place. Protocols such as IP, Internet Protocol, and ICMP, Internet Control Message Protocol, operate at this layer. The network layer determines the best path for data to reach its destination. Like when you send an email and it traverses multiple routers to reach the recipient. 4. Transport layer. The transport layer ensures complete data transfer. It manages end-to-end communication, flow control, and error recovery. Key protocols here include TCP, Transmission Control Protocol, and UDP, User Datagram Protocol. TCP ensures data packets are sent, received, and reassembled in the correct order, whereas UDP provides a faster but less reliable connection, ideal for streaming. 5. Session layer. The session layer is responsible for establishing, managing, and terminating connections between applications. It handles session restoration after a disruption. For example, when you pause and resume a video call, it's the session layer at work. 6. Presentation layer. The presentation layer acts as a translator for data formats. It ensures that data sent from the application layer of one system can be understood by the application layer of another. This layer handles encryption, decryption, and data compression. Think of how a web browser displays a web page correctly, even if the data arrives in a different format. Finally, 7, the application layer. Application layer is the closest layer to the end user and interacts directly with software applications. It provides services such as email, file transfer, and web browsing. Protocols like HTTP, FTP, and SMTP function at this layer. When you click a link on a web page, the application layer initiates the communication process. So why is this OSI model so important? The OSI model offers a common language and reference point for network professionals. By breaking down communication into layers, it simplifies troubleshooting, design, and implementation. If a network issue occurs, knowing which layer is affected can help isolate and resolve the problem efficiently. For example, if two devices are physically connected but unable to communicate, the issue might be at the data link or the network layer. In practice, the OSI model helps explain interactions in various scenarios. Let's say you're streaming a movie. The application layer starts the request to stream. The transport layer ensures data packets are sent and received correctly. The network layer routes the data through the internet. The data link and physical layers manage the actual transmission over cables or wireless signals. This structured approach allows engineers to focus on specific layers for optimizations or diagnostics. So while the OSI model is comprehensive, the TCP/IP model is more widely used in practical scenarios. The TCP/IP model has only 4 layers, which correspond to different groups of OSI layer: link, internet, transport, and application. Though simpler, the TCP/IP model aligns well with real-world networking protocols, making it popular in practice. Understanding the OSI model is critical for anyone involved in networking or IT. It offers clarity on how data travels from one device to another, outlining responsibilities at each stage. Whether you're troubleshooting a connectivity issue or studying for a certification, a firm grasp of the OSI model structure can make a significant difference in your technical expertise. Thank you for your time, and I hope this overview has enhanced your understanding of the OSI model. Until next time.